All right, how do you find area between the curves if you had two functions like this? Well, here, this one doesn't work the way we were looking at the previous ones, because if you try to do the top minus the bottom, we don't actually even have functions that exist at that spot. Plus, on some of these, like the top and bottom might be like the exact same function here. So what you have to do in these ones is instead of doing top minus bottom, you're thinking uh, uh, the difference of these from side to side. And so what you're going to have to do is figure out what is this function in terms of y, what is this function in terms of y, and then subtract them. And when we subtract them, it's just like we did with the other ones. If we kind of rotated this to look at it as if it were a top minus bottom type problem here, uh, it ends up being this one minus the one on bottom, which if we rotate this back, you can see is the one on the right minus the one on the left. And the reason it's right minus left is we're looking at the ones furthest away from the rotation line. Our rotation, or the one, or not rotation, but the line we're taking the area from, it's for the one further away minus the one that's closer. So that's why we end up going right minus left here. So the integral would end up looking like this, very similar to what it is. One thing to notice, our limits here come from the y-axis now, not the x-axis. So you got to take your limits from there. Let's try an example. What is the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. Notice for some of this we would be okay taking top minus bottom, but over here it's the same one. So what we're going to do is switch this. Instead of going top minus bottom, we're going to do right minus left. So the one on the right, right here, we got to get that in terms of y now. So we want to solve it as an x equals equation, which if we add the 1 over would be y plus 1. We want to do same thing with the one on this side. So we want this as an x equals equation. So let's solve this here. Let's subtract the 6. So now we got y squared equal, minus 6 equals 2x. And now let's divide it by, all of them by 2. And so if we do that, we get this equation that's going to be x equals y squared over 2 minus 6 divided by 2 would be 3. So we got these two equations now that we're going to be using on this one. So let's see if we can write out our area integral. We want the one on the right, so that would be y plus 1 here, minus the one on the left, that would be our half y squared minus 3. This is going to be a dy one, and now we need our limits here. That's going to come from where these are intersecting. Now, the picture's here, so if you have a picture, you can definitely use it. We want to pick what are these y values. So the y values would be 4 and negative 2. Now, if they didn't have those there and all you were given what was written up top here, then you're going to have to solve for those. And you would solve same way we've done on other problems where you put those equal to each other. So set the two functions equal and solve. So if we set these both equal and solved it, you got to get everything to the same side. So I'm going to minus the y over, I'm going to minus the 1 over 2. If you times or multiply through by 2 to clear the half, we get this. Now if you factor that, you get this. And if you solve this, see how we get 4 and negative 2, the same two numbers we got up here. So that's how you do it if you did not have the picture to work with. All right, so now to solve this, we've done a lot of these already. So let's use our calculator to evaluate. So we'll do our integral here from -2, -2, -4, -2 to 4. When you're entering these in, just like we got over there, make sure you put parentheses. Now, we don't have a y, but as far as calculator is concerned, what your variable in is does not matter. So we'll just use x here, minus, start a new parentheses, because we want everything in that other one to get subtracted. So once you got it all in there, now what we want to do is just hit enter, and that should give us the approximation. It's sometimes like this one, when you're dealing with polynomials, should be able to get more of an exact answer here. So 18 would be the area between those two curves.